So kinematics is concerned with describing the motion of an object, but not how the motion actually started. So in this video, we're going to define a bunch of new quantities that we can use to describe the motion of an object. And we're going to start with one-dimensional motion, meaning that the motion is going to be along a straight line, either the x-axis or the y-axis if we're looking at a graph. So the first is displacement. The displacement of an object is just the change in position. And it's a vector quantity, so it has a magnitude and direction. And the direction is pointing from the object's initial position to its final position. So if we have this object here that starts at this point x equals 2 and then moves to x equals 10, the displacement is just the final position minus the initial position, or positive 8. And the unit of displacement is meters. So we can make this coordinate system however we want. So usually you make right the positive direction and left the negative direction. But there's nothing stopping you from making left the positive direction and right the negative direction. And you can also make the origin of the coordinate system wherever you want. So here the initial point was at x equals 2. Well, usually you'll want to make the origin of your coordinate system at the object's initial position. So that way at the initial position x is equal to 0. So, but let's say we made the origin of the coordinate system at his final position. So here x would be equal to 0, and the initial point would be x equals negative 8. Well, his displacement will still be positive 8 because you just do the final position 0 minus the initial negative 8. So even if we make the coordinate system different, his displacement will still be the same because we're just looking at a change in position. So the next quantity is the average velocity, which is a displacement divided by the time interval during which the displacement took place. So if this guy made his 8-meter displacement in 2 seconds, his average velocity over that interval would be 4 meters per second. And so average velocity is also a vector quantity which points in the direction of the displacement. So if we made a graph of the particle's position versus the time that's elapsing, then the slope of a line between 2 points is going to be the average velocity. Because slope is just change in y over change in x. And here, a change in y is the displacement, while the change in x is the time interval. So the slope on a position versus time graph represents the velocity. Now we also have the instantaneous velocity, which is the velocity at a single point in time. So on the graph, that would not be the slope of the line between 2 points, but the slope of the tangent line at a single point. And we can also represent it as the derivative with respect to time of the position function. So next we have distance. While displacement is just the final position minus the initial position, distance depends on the path that the object took to get to that point. So if the object started here and ended here, then the displacement would just be the length of the straight line between those points. And that would not depend on the path that the object took. So even if the guy went along this squiggly line from the initial to final point, then the displacement would still be the length of this straight line. while the distance would be the length of this long squiggly line. As another example, if we went back to this guy, starting at x equals 2 and ending at x equals 10, let's say what he actually did is start at x equals 2, and then he went over to x equals 12, and then he went backwards to x equals 6, and then forward to x equals 10. Well, his displacement would still be 8. It's just the final minus the initial position. But his distance would be, so he went from 2 to 12, that's 10 meters, and then over back to 6, that's another 6 meters, so 16 meters so far. And then he went back to x equals 10. So that's another 4 meters, so his total distance traveled would be 20 meters. But the displacement is always the same. So now we have average speed, which is the distance divided by the time interval, as opposed to average velocity, which is the displacement divided by the time interval. And the instantaneous speed is just the magnitude of the instantaneous velocity. Because the instantaneous velocity can be positive or negative depending on if the particle is moving to the right or to the left. Well, the instantaneous speed is just going to be the positive value of that instantaneous velocity. So distance and speed are both scalar quantities. They're always going to be positive, and they do not indicate a direction, while displacement and velocity are vectors. So the positive or negative sign on the displacement or velocity is the indicator for direction. The positive or negative indicates if the object is moving to the right or to the left. So lastly, we have the average acceleration, which is another vector quantity, and it's defined as the change in velocity divided by the change in time. And the units would be meters per second squared. And we also have the instantaneous acceleration, which is the acceleration at a single instant in time. And so that's going to be the derivative of velocity with respect to time. So the acceleration does not always point in the same direction as the velocity. It's going to point in the direction of the change in velocity. So let's say we have these two vectors here, velocity and acceleration. Now this tells us that the object is moving to the right because the velocity is pointing to the right. However, the acceleration is pointing to the left. So that means the velocity is getting smaller and smaller. So the speed of the object is decreasing. So the velocity is getting closer and closer to 0. And then when it reaches 0, it's going to start becoming negative as long as the acceleration is still pointing in this direction. So then the object will turn around and then move in this direction. And then once the velocity is pointing in the same direction as the acceleration, then that means the object is going to be speeding up, because the acceleration is making the velocity bigger instead of smaller when they're pointing in the same direction.